Support for the Blueprint podcast comes from the SANS Institute. Defending against attacks is an ongoing challenge with new threats emerging all the time. If you're looking to level up your blue team skills or want to enhance your current skill set and become even better at defending your organization, then consider signing up to attend the SANS Cyber Defense Forum and training beginning on Friday, October 9th. We are planning to bring together prominent cyber defense practitioners from leading organizations for a day of in-depth forum talks, followed by a week of closely aligned training and bonus sessions. The Cyber Defense Forum is a free virtual event. That's right, it's a free virtual event with live stream talks with experts you don't want to miss. Once again, that happens on Friday, October 9th. To get signed up right now, visit sans.org/summits.
This is Blueprint, the podcast bringing you the latest in cyber defense and security operations from top blue team leaders. Blueprint is brought to you by the SANS Institute and is hosted by SANS certified instructor John Hubbard. And now, here's your host, John Hubbard.
Today on the Blueprint podcast, we have Austin Taylor, a SANS instructor and director of cybersecurity research and development at IronNet. Austin is an expert in data science, not just that, but as applied to information security. We talk everything from data science and what it's good for and what it's not good for, how it's used and misused, to specific algorithms. Stay tuned for this episode with Austin Taylor. Austin, welcome to the podcast. Thank you for being here.
Thanks for having me, John.
So I'm really excited to talk to you today because I remember when we first met, I think it was probably 2017, was it, that first SIM Summit?
It sounds right.
A few years back, I remember me and you and Justin Henderson were sitting around talking at the summit there about data science. And I remember thinking, Austin has a really, really good way of clearly explaining these kind of concepts, saying what the strong points are of machine learning and data science, where he's struggled to apply it, where he's seen good success. And so that was what made me want to bring you onto the podcast. I think you have a really clear way of doing that. So I'm excited to get into some of that sort of stuff today. Before we get started on this, I know like data science and machine learning and all that is not something I'm super familiar with, and I'm going to assume the audience is probably in the same boat as me. So to kick it off, let's do a quick kind of definition of terms. Data science versus artificial intelligence versus machine learning, deep learning, and all of that stuff. Can you give us a quick summary of like how all of those things fit together and that sort of thing?
Yeah, that's a really good question. So I always think of data science as, yes, there's a lot of statistical stuff and artificial intelligence, machine learning, and deep learning. They're all components of data science. But at the core, it's taking data and then creating something actionable from it. So whether you're taking a large set of data, and then the challenge becomes like, which algorithms do I apply to a specific use case to create actionable information for the end user, whether it's a business entity or an analyst or whoever you're working with. You have to know what are the right mechanisms for me to apply to get the information that I need out of the data.
Yeah, so this is obviously a super complex topic. What is it that brought you personally into data science, and what is your background that brought you to where you are today?
So I did want to talk about a little bit more about deep learning, machine learning, and artificial intelligence, just
sure, yeah,
to clear up those.
Yeah, absolutely.
You hear these terms a lot, especially in our cyber defense industry today. You hear artificial intelligence. I don't think you can go to a conference anymore without hearing machine learning or deep learning or something like that. And so what does that actually mean? When you see people using artificial intelligence in an ad, they're technically not wrong if they have any element of machine learning, which there's very complex implementations of machine learning and there's very simple ones. You know, a simple example would be doing some type of basic regression or making a prediction about if a domain's good or bad, but they don't really get into any of the performance metrics behind that. So just at a high level, artificial intelligence is sort of the broader umbrella in which machine learning and deep learning fall under. So underneath artificial intelligence, that's just where you could think of that as machines. You're enabling a machine to mimic some kind of human behavior. And then underneath that, you have machine learning, which is the subset of AI. And then that's really where the core of all the practice comes in knowing which algorithms and which classifiers to apply to certain data sets. And then underneath that, there is deep learning. So deep learning is a subset of machine learning, So if someone's making the claim that they're using deep learning, then you know that they're at least applying some machine learning, and they usually are applying deep learning. When you think of multi-layer neural networks, very popular for image recognition, but it's become even more popular lately within the cyber defense industry.
Gotcha. And so what kind of background do you have and what brought you into these topics as a specialty that you were interested in?
Yeah, so that's a good question. I actually used to do a lot of network analysis over at Booz Allen Hamilton. And so I didn't know how to code very well. I picked up coding sort of on the job there, and I realized there's a ton of data here. This is back in 2012, and we were working with so much data that it wasn't enough for me to just do a simple for loop and work with and ask the questions that I needed to of the data. So I met with one of my friends named Charles, and he kicked off this course. It was a intro to data science course. And that was where I really got into the fundamentals of data science. So things like, this is a database and this is how it's structured. And there were really 4 areas that I found that were good. So the fundamentals of programming, that's a super important one for data science. There was a concept of cloud computing. So all of, working with large data and what is big data even mean? There's a bunch of different definitions for that. And then how do you work with these large complex data sets? And visualization is another popular topic for discussion, because if you have a good visualization, you can really tell a nice story that caters to the data with just the valuable information. And I think finally the other areas, so you got coding, databases, visualization, and machine learning. Knowing which algorithms to apply if we're doing unsupervised machine learning or supervised machine learning. And then within those respective areas, which workflows should we apply to the data set? How much data do we need for each area? And all kinds of. So I really got fascinated with that. And I started applying a lot of that to cybersecurity problems. And I realized if you know basic machine learning or basic data science and apply it to the cybersecurity space currently, you can get to the end of human knowledge pretty fast within the space where you start looking for stuff. Well, how can I detect beaconing or DGA or stuff we'd want to see as an analyst and try and make predictions on it? And there's a couple articles published, but sometimes you're just going to have to be the person to find out how to apply the right machine learning model, or even come up with one on your own and apply it to that specific use case.
So in terms of the problems that, you said you get to the end of human capability, and I think that's how you phrased it. What's the problem set that you can solve maybe better with machine learning versus like traditional, IDS or other kind of analytics applied by any traditional kind of security equipment? What is it about machine learning and what can you do with it that's beyond what we've done so far with the traditional stuff?
We'll be back after a quick break.
If you're enjoying this episode, then you're undoubtedly interested in building the strongest security operations team that you can. For those who want to go even deeper, did you know that SANS has not 1, but 2 courses that cover security operations centers as well? For the leaders, managers, and directors out there, my co-author Mark Orlando and I offer 551, Building and Leading Security Operations Centers. This course covers building your team, your physical and virtual workspace, getting the right data into your tools, and then focusing on security priorities through everyday execution of important security tasks and building the best SOC team possible. For the technical practitioners out there, my course Sec 450, Blue Team Fundamentals, Security Operations and Analysis is designed to cover everything you need to jump in being the best SOC analyst that you can be. We cover important data types, SOC tools, security logs, malware, analysis technique, automation, and much, much more. In addition, if you want to prove you can deliver the best on any security team, both courses have an accompanying certification available from GIAC. That's the GSOM for 551 and the GSOC for 450. Check out both courses and free demos available on the SANS website. You can get registered today for an in-person course at one of our many events, or go to On Demand and take either class anywhere at your own pace. Thanks for listening.
Yeah, so when you think of machine learning, typically within the cyber defense space, most of the time we're referring to, I would say, so within machine learning, there's unsupervised machine learning, there's semi-supervised machine learning, and then supervised machine learning. For most use cases, as an analyst, we're probably more concerned with the supervised machine learning realm. And the reason that is because the supervised machine learning, you're typically doing binary classification, which is yes or no. Is this thing bad or is it good? And it becomes difficult based off the data set that you have to always answer that. There are cases where unsupervised machine learning would apply really well, but for the most part, we're probably more focused or concerned with supervised machine learning. So with supervised machine learning, we can apply that to maybe taking a look at a domain and making it specific to a use case. Supervised machine learning becomes specifically useful when, if you see an analyst, we've all seen the analyst with 10 or 20 tabs open when they're processing an incident or something like that, or trying to form some kind of conclusion about domain, for example. Well, with machine learning, we can take each one of those tabs, if you will, and ask questions like, well, why did you have that tab open? Oh, you were looking at a domain. You wanted to see how old the domain is. You wanted to, maybe it's on a known threat intelligence list. And these are all things that we can call features and put it straight into a machine learning model. And then the more data we get, every one of those tabs could just become a feature in a machine learning model. And then the model can start making predictions and try and start automating what was in the analyst brain. So now you're able to make those decisions at scale and much faster. And the machine's doing the work for you. So the analyst can focus more on analysis and not so much data gathering.
Yeah, so that's an interesting kind of way of explaining it. So, having the tabs open and all that kind of stuff, that brings us to, I guess, what SOAR is doing a lot of the time in a lot of cases as well, like automation. We're saying, go look up some sort of data for us and tell us yes or no, does virus total or, whatever, think this is a bad domain. How is doing that just kind of automated lookup different than bringing it into maybe a data science model? Is it the combination of getting all of those answers and then coming up with like a yes or no based on all of them?
Yeah, and I see SOAR fitting into all of this as a machine learning model prediction would just be a step along the way, where SOAR, you're integrating your entire ecosystem. So you can take the output from a machine learning model and then make a decision based off that. Do I actually want to escalate this to an alert or send an email to somebody? Where if you're using your SOAR, most SOARs charge for an action. So if you're doing all of that action within the SOAR, it could get a bit costly. I know some, without mentioning any names, there was one company that would, for every, I think 15 actions, the trial, they'd give you 15 actions. And I was like, 15 actions, that sounds okay. And then I realized that's not even enough to properly enrich a single domain to get all the data that I need from it. So you can just include all of those questions and create these things called features within your machine learning model. Then you train that model nightly. And then as more data comes in, you're not enriching the domains at that time. That data has already been stored. And as new or novel domains come in, you're now making predictions about that domain based off all the historical data that you've seen. So it's a little bit different of a workflow. Maybe you could even use a SOAR as some type of expert system where it's going and retrieving the data on your behalf, but then you would want to store that data off into a database and train your machine learning classifier maybe nightly. And then as new domains come in, you can start to make predictions about it based off the data that your SOAR's gathered for you.
Gotcha. So if we were trying to do supervised machine learning on something like you said, good or bad domain, or is this a virus or is this not? Walk us through what kind of things you might be looking at in terms of like features and how you would kind of capture that and what kind of, I guess, what would the training process be for, that sort of thing? I know that's a really big question.
I love it though. It's so good because there's so many different features you can apply to a domain. And I will say this is common. We're talking about a domain here and making a prediction if it's good or bad with supervised machine learning, but there's so many different applications for supervised machine learning. But I think for this discussion and keeping it simple, it helps just to focus. We're all familiar with what a domain is and some of the features around a domain. So typically when we get a domain, we're asking at the end of the day, if you're an analyst, we really only care, like, is this good or bad? I mean, would you say that's fair?
Yeah, definitely. With some level of gray, right? Like how sure are we that it's bad?
Yeah. But there's different flows for different use cases. And I think that's an important distinction. I might be more concerned about properties of a domain if I'm looking for something like a domain generation algorithm and it created this domain versus if it's a phishing domain. Those are going to exhibit different properties that I'm going to care about. And so therefore, it's important to focus your machine learning to a specific use case when you're building your model and coming up with these things called features. So if you're just starting, if you were just like, hey, I want to start doing some machine learning, the basic flow or the workflow for that, the number one thing you got to get is data. Data is by far probably the hardest thing to do with all this. Now, there are use cases with, for example, like DGA. And I heard someone say the other day, they were like, well, DGA, what is this? 2009? Like, we don't really see DGA anymore. And funny enough, I just read an APT was using DGA to successfully evade an IDS like last month. So
yeah, that doesn't surprise me. I mean, it still would work beautifully in most environments.
Yeah. And so DGA is a beautiful thing because you can dynamically generate data. And so there's really no shortage of it because you can create it. Now, within DGA, the seeds change and those are set by whoever's creating the dynamically generated algorithms. But there's no shortage of data. And there's actually Endgame put out a really nice repo that has a collection of different DGA algorithms out there. So if you're looking to build some labeled data, so that'd be step one. You want to build your label data specific to a use case. So whether it's phishing or I want to catch DGA or DNS tunneling or, all the other use cases out there, you have to first gather your data. The next step would be to do some type of data normalization. So, okay, I have all my data. Maybe it's in a bunch of JSON files or CSV files. I need to put that into a common format that I can use. So I like to use Pandas data frames as an example. They have a really great data normalization process. It really works well with nested JSONs. But you can read that data into a data frame. And if you're not familiar with what a data frame is, you can think of it as like an Excel spreadsheet. It's a vectorized object where you can apply a function to an entire object. So if I want to, multiply an entire column by 5, for example, I'm not doing a traditional for loop through all of it. I'm just taking that vectorized object and applying times 5. So I could say data frame, column times 5. Yeah, I don't know. Little thing there. Okay, so anyways, back within this data frame, the more features we get and the more questions we can ask about a domain, we can start extending our columns within this data frame if we're thinking about it like a spreadsheet. So one popular feature is domain age. John, I know you're familiar with the age of a domain and the likelihood that it could be potentially more malicious or at least suspicious and worth investigating if it's a newer domain.
Yep, absolutely. Exploit kits, all that tend to be, created that day or otherwise.
Yep. Now, with specific to something like DGA, a lot of those domains aren't going to exist. So it's going to generate those NX errors and those NX records within DNS. So maybe that's something we look at. Like, okay, we can take a look at the NX records that are getting generated and maybe treat that as a feature. So instead of, going through your DNS logs and saying, oh, wow, this domain generated 400 NX errors or NX records, we can just say, as a feature within our machine learning model, we would treat that as how many NX records belong to this domain. And it would say like 400 or 500. The goal with the features is we want to try and get everything down to a number in some form or fashion. You can take strings, and there's a method called one-hot encoding and like word2vec, where you're taking those words and then essentially, like let's say you had a list of or a column full of words. A machine learning model can't really use that the way it is. So one method or one technique to do that is you would take that list of words and create a unique column for each one of those words and then put a 1 or a 0 if that value is present. But you could see where that would add a lot of extra columns and a lot of
right.
sometimes unnecessary complexity. But one thing I've seen that applied really well is with top level domains. So like the .coms, the .nets, the .xyzs and the .biz. So get the data, all the questions. This is where the tabs come into place. So if you have one tab open normally in your, on your favorite site to enrich it and get the whois date, and maybe you're looking at like the ASN and doing some analysis around that. Those are questions that you can take and automate and put into a machine learning model. And then as those domains come in, as a new domain comes in, all of those questions, they get automatically applied to that domain and stored in this spreadsheet, if you will, which is typically a data frame or machine learning model. Okay, so once you have a list of features, then it's time to train the data. It's kind of exciting. So how do you know which algorithm to apply? And this is where it kind of gets tricky. There is a very popular framework called sklearn for machine learning within Python. And within sklearn, if we're doing supervised machine learning, there is a framework called Ensemble. And what this will do is it's the idea of instead of applying a single machine learning model or a machine learning algorithm or classifier to a use case, what this will do is apply multiple. And you can see which one will perform the best based off the type of data that you have. So typically these will run, if you're running these each night, random forest is a popular one for ensemble methods. There's a whole list of ensemble methods over on their site, but you can run these different ensemble methods through, or you take all your data, you apply all these different methods to it, and then you see which one performs the best. And that's the machine learning model you can use for whatever use case you want to have for that day. And the output of all of that is going to be good or bad. Is this domain good or bad? And then with some kind of confidence score. That confidence score is going to improve based off the types of features you have and the amount of data you have. So you generally want to have a nice variety of data and a nice volume of data. There's a few V's to follow. Velocity, like the speed at which you can actually get the data, the volume, and then the variety. So the more data that you have to collect, if you have a very small set of data, it's easy to come up with features for it. So maybe I have 10 or 20 records, right? Which is like extremely small for machine learning. Then you're at risk for something called overfitting, where you can start making predictions on your data. So I can take those 20 records you put together and say, pull out the features that I think are important from that, and then make a prediction off that same data. And I'd be right 100% of the time. And you'd be like, wow, this is incredible. Machine learning is amazing. But if your machine learning model is right 100% of the time, something's wrong. There is a very high likelihood that you have overfit. Like it's too specific to that data,
Yep. So the algorithm thing, that's one of the things I wanted to tease out here. I don't know if this is dangerous to try to explain via podcast, but I know there's things like decision trees, and you mentioned random forest. I know there's, regression and k-nearest neighbors and that kind of stuff. Which one of those, if listeners wanted to dive into maybe an example of how this works, which one of those is typically used? And if you could explain kind of in podcast friendly format, how such a thing would make a decision on good versus bad or categorizing something. Is that a possible thing to do?
Yeah, definitely. There's a classic example for this. It's actually like, if I'm going to go play golf, for example, today, and the output is, should I go play golf? Well, this would be a perfect use case for a decision tree where there's usually some considerations that come into play if you decide you want to go play golf for the day. Is it sunny outside? Is it overcast? Is it rainy? What's the weather like? And then if based off whatever the next step is, so if it's sunny, well, then there's some additional considerations like, well, it's sunny, but how windy is it out? And then if it's too windy, if it is windy, then I'm not going to go golfing. But if it is not windy, then I'm going to go golfing. Decision trees are nice because you can visualize and visually represent the thought process and the decision-making process that your machine learning algorithm or model went through. And that's nice. So if you have to explain how machine learning is working to a manager, you can actually generate a nice picture for it, Yeah,
I remember you showed me at one point, I think, the decision tree for, is this domain good or bad? And one of the ones you had generated, and it was, I would say, probably way more complex than the way I decided whether I'm going golfing or not. It was, I don't know, hundreds of decisions, thousands.
Yeah. And that was based off a small subset of features. I think there were 7 or 8 features for that model. And when I say features, I was asking questions like, how old is this domain? How long is this domain? How many periods are in this domain? Those are all features you can generate yourself. There's actually a nice list of features online. You can search for cybersecurity domain features, and it'll help you answer some of these questions. I also have some examples in an open source framework I have out there called Flare, where it'll do some of these enrichments and pull out some features for you.
So beyond decision trees, that one sounds like it's probably one of the primary ones used for information security and malicious, domain detection. What other ones are used?
Well, there's a ton. One of the most popular ones for unsupervised machine learning is k-nearest neighbors, just to do basic, like how close to this object is another. Popular one is like the e-distance of something. So we've seen that. I know, and it comes with Elastic now, where you can, applies the Levenstein distance formula to the difference in words. So if there's a small subtlety in a domain where maybe someone changed a letter and they're trying to send it to you to spearfish you, it'll tell you the difference in characters to apply. Yeah, and then there's always the use case for doing basic regression. I really don't feel like there's a lot of good use cases for regression within cybersecurity, just because the data is so different from malware group to malware group. And, if you're following the MITRE attack matrix, they break it out into threat groups and then malware families.
Yeah.
So it's like, how there's so many different variants of that, and getting enough labeled data to actually make meaningful and informed decisions, it becomes difficult for some of those use cases.
I remember one of the things we were talking about back, I think it was 2017, that first time we had met and we're all talking with Justin and everyone. You had said, you had spent a ton of time going through, I think it was IDS alerts you had mentioned specifically, and saying like, could you apply machine learning to the data that was present, and that there was no like magic bullet to getting it right every time, and that you needed to add additional context and domain knowledge and stuff on top of that. Is there, obviously looking at age of domains and that sort of thing is a good use case for this. Are there any other, common cybersecurity problems that you're having really, really strong success with machine learning methods versus the traditional kind of approaches that, people should be looking into?
So just to rephrase the question, are there specifically great use cases for machine learning?
In other words, what are the best possible use cases other than the domain good or bad? Like, where are you seeing success in a way that's reachable for the average organization, perhaps?
Yeah, so I primarily work within the network space. If you've looked at how many different areas there are within cybersecurity, I forgot who puts out that Cyberscape 2.0 picture, the Momentum Partners, I believe. Basically, there's 50 different categories within cybersecurity, and then each one of those categories could have their own use case. But specifically within the network threat analytics space, I've seen a lot of success using machine learning for use cases like anything where there's a domain involved. So your DGA, your DNS tunneling, I think there's so many features within DNS tunneling, and looking at the entropy and splitting out, machine learning has a strong presence there, and it's been pretty successful. And then there's some, more complex machine learning use cases for things like lateral movement. I don't know how much I can get into on that, but there are some algorithms that you can apply for there. I'm trying to balance out, I don't want to give away any company secrets.
So here's where my mind went when you said that. User behavior analysis, right? A lot of the, in my experience, a lot of those tools are telling you, hey, John logged into this computer that he's never logged into before, or this computer talked to this computer that it's never talked to before. Is that one of the spaces that machine learning is being applied to in this sort of a more accessible and more common way, or is there better uses than that?
No, absolutely. That, in fact, kudos to Microsoft. Their advanced threat analytics is amazing, and they have all the right data there, because they're hooked right into their own operating system. But those are perfect use cases for regression to detect anomalies in user actions, where maybe there's, Bob logged in at an unusual time, or maybe you want to take a group of peers and do some kind of classification to see if that's normal behavior. You can also do some type of clustering for separate groups of users to detect outliers. And then where it gets really powerful is when you can connect all of those use cases and those different models and tell a story to a user.
So ultimately, one of the things that I was going at with my previous questions is, I often see SOCs and businesses in general saying, oh, we need something new. We need fancy, data science and all of that sort of thing. If people are going to buy a data science based anything for security, right? What is the product category or detection type or otherwise that you would steer someone towards? Or do you think that maybe there's other things that, are best? I'm going to guess the answer to that is no, because you're a data scientist, right? Yeah. But I often hear oh, we need data science. Where do we go? What's the first thing you would do in terms of acquiring a data science based security solution?
I think the most important part to that question is figuring out what problem they're trying to solve, and just knowing that data science isn't a silver bullet. I personally don't consider myself a world-class data scientist. I've just picked it up enough to apply to these use cases and just deal with it every day, I meet so many talented data scientists and I'm wow, that guy's really brilliant. But what they don't have is the cybersecurity expertise. So they really have no idea what to apply it to.
That's one of the things I remember having a discussion before. I was he knows data science and he knows cybersecurity. So that's one of the, unique things I think about you. You have the perspective of both of those. And so you have a good grapple on, what are the actual use cases versus the theoretic kind of academic, what could we solve? And so that's why I would,
Something I've learned is there's really good use cases for machine learning, especially on endpoint data. And it becomes the more data you have, the better off your machine learning models are going to be. And what I mean by that is we've had some really great success within the network threat analytics space for specific use cases, and other use cases, like domain fronting and some of our other analytics we've had to shelve because we're just like, there's just not enough data. If we're limited to NetFlow and to packet captures and sensor data, it's just, we need to see that endpoint information to create an event that has actual meaning for an end user. We can create events all day long and make predictions all day long, but if there's a 80% false positive rate, then are you actually adding any value?
Right. So that's actually an interesting statement. Are you unable to do well purely based on network data and need endpoint because of encryption, or is it just more and more features that you're collecting?
Yeah, that's a really good question. Yes, the answer is yes. With specific use cases, so one popular one is, so somewhere where we've had a lot of success is suspicious file download, for example. We can make pretty accurate predictions of whether or not a file that was downloaded is suspicious because there's a lot of properties and features there. But somewhere where we haven't had as much success is with anything that has to do with, not anything that has to do with TLS. There's an invalid cert chain analysis that we would do. If a certificate had an invalid cert chain, we could make a prediction and we could tell you there's an invalid cert chain here. And, like the certificate authority that signed this, something's not right. But what's after that? Like the analyst is going to say, okay, well, there's an invalid cert chain.
Yeah. Like let's say, but if you don't have a decrypted version of it, right? Yeah. Stuck if you don't see the endpoint and what the file actually was, right?
Exactly.
Yeah, that makes sense.
Even stuff like beaconing, So something that we've tried to do is treat those as data points that add context to a scenario instead of saying this beacon is good or bad. Because so many things beacon, like there's benign use cases and there's malicious use cases, and trying to distinguish between both of those gets super challenging. And that's where features and having that endpoint data, if you can answer and tell me which process was responsible for generating that beacon, that adds so much more context than doing analysis around the domain, in my opinion.
Yeah, that makes a lot of sense. I remember one of the stories I always talk about in class is when I believe this was the story, you ran Flare for the first time on your traffic from your home network and you found you have a particular IoT device. I won't spoil it. Like that kind of thing, right? If you could summarize that story, I think that's probably a pretty good case of like, it's beaconing, but it's not necessarily bad.
Yeah. So that was a funny story. So Justin had called me before we, kicked off and we had Flare in the class and everything. He's like, hey, I want to get some command and control type capability for detection. I was like, oh, I could write a little beaconing framework or put something together. One of my colleagues, John, had already started putting something together. So I bundled up Flare and ran it at the house for the first time over my Elastic stack. And there was an IP address that came back, and I noticed something was beaconing every 5 seconds. It was up in 5-second intervals. And I was like, oh my goodness. Now, when you first start dealing with any type of temporal data or something like beacons, you kind of just think everything's bad at the start. I don't know if it was like that for you, John.
Oh yeah, absolutely.
I was like,
then I realized everything does it.
Yeah, like everything's beaconing. So, I ran it over flow records. So you have the source IP and dest IP, and one of the IPs, the IP that was beaconing in 5-second intervals was going back to an AWS instance. And then when I looked at the TLS certificate in the SNI field, it was my ceiling fan. I don't know if I could say the full name on here. It's a popular ceiling fan with big
known for being large.
Fans. Known for being large, yeah. So basically my ceiling fan was beaconing out. And I messaged him about it and I was like, why is my ceiling fan beaconing every 5 seconds? They're like, oh, we're just checking for firmware updates. Like, who needs to do that every 5 seconds? And so they've changed that since, but I haven't seen what the new interval is recently. But yeah, that's a good use case of where something looked super interesting and, it turned out being benign.
Yep. On the flip side of that, is there any poor usage of data science out there where you're like, people are trying to use this and there's totally an easier way? It doesn't need to be done like that or anything like that.
Yeah, I see this a lot with web shells specifically because I think, so one use case, I saw an organization trying to apply detection of web shells using machine learning, and they tried to connect the payload for the traffic and associate that with a domain. But that just doesn't work too well because there's properties about a domain that make it interesting and potentially malicious. And there's properties about a payload within a web shell. And there's properties within the URL and there's things like that. But in some cases, a signature is just the way to go. Like it's You can tailor a signature. The only problem with signatures is it's got to be discovered already, and it has to be more of a known bad, where you can take a lot of the properties out of the payload for a web shell and start making predictions. But I would recommend doing predictions about that specific payload if the payload's a web shell, and not trying to, this has been done successfully where people would take a domain and then maybe output a confidence score of the likelihood of that being bad based off, things like creation date, the length of a domain, the entropy, and how many slashes and dots and equal signs are in there. And then also doing the same type of analysis of the body of a payload, and then connecting those two outputs together. Sometimes the outputs just don't always go too well together, because in some cases there's going to be encrypted traffic. In some cases it's going to be decrypted. And so now you're working with much different data sets for making predictions on. So I guess to sum all that up, the more uniform and consistent you can make your information to a specific use case, the better output you're going to have and the better the predictions are going to be.
One of the other things I thought was enlightening that you said, I don't remember how you phrased it, but things right, that we can write a signature for versus things we don't know. It seems to me that data science is probably much better at picking out the anomalies and the stuff that we don't know is bad yet we don't have a signature for. And so making a complete defense might consist of, obviously signatures for all the known bad, and then supplementing with data science and machine learning methods for the unknown unknowns and that sort of thing. Is that a fair way to put that?
Sure. Yeah. Use machine learning to discover the unknowns, if you will, and then write a signature for it.
Yeah. Those new attack tools that no one knows exist, right?
Yeah. Actually, Darktrace had an interesting article. They caught APT41, and they said they used machine learning to catch APT41. And I went and I read the article, and I was like, well, it's interesting that I think it was catching an APT41 exploiting a 0-day. That's how it was worded. Mm-hmm. And within the article, they do a great job of showing the relationship between machine learning and signatures. I think both have a nice role to play within defense, because then if you go and read the article, so I was totally expecting to read these like mind-blowing machine learning algorithms, but what actually tips them off to this 0-day exploit was a JA3 signature.
Oh, wow.
Yeah. Within, it was a possible command and control as a category, and they're just running JA3 over TLS. But then within that, they're able to say like, oh, and this is also beaconing, and this is also exhibiting some other type of behavior based off some of the models. But that's really how I think machine learning should be applied together. You use machine learning within specific use cases applied to the kill chain, but it needs to be applied together with both endpoint data, signatures, and getting enough of that data to have the best efficacy for your whatever use case you're trying to address.
Yeah. So if people are going to look into this sort of thing, what tools, what websites, resources might someone start down to try to kind of get their head wrapped around this large world of machine learning and all of this for information security specifically?
So I would, if you're just getting into data science, I would start with the fundamentals. There's some great classes online, and you can Google how to learn data science. There's also some really good talks, some SANS talks I've seen. I know I've given a couple.
You did a really cool one. I think it was the second year Sim Summit. We did the DGA example, and I think it was some Bayes algorithm somewhere in there. Anyway, yeah, Austin's got some great stuff. I'll vouch for him. Thank
you, John. Appreciate it. Now, there's also, a couple years ago, data science wasn't as popular in the cybersecurity space. Now it's like booming. Like everyone's getting into it, and there's so many more resources out there. I think for me to just, give a specific website, I don't know if it'd be doing anyone any favors, but I would say Google, honestly, like whatever use case. If you want to just learn data science for cybersecurity, when you start reading data science applied to cybersecurity, you're going to have no idea of what you're reading.
It jumps in too hard, and you got to start with the basic case and then work it up.
Yeah, I think if you understand the basic concept at a high level of what problem data science is trying to solve. So basically you have a bunch of data, you want to normalize that data. Then you have a decision point. Do I want to apply unsupervised machine learning or supervised machine learning to this? And then that's going to dictate, okay, well, if I'm doing supervised machine learning, I know I need to have features. What features can I pull out of this data, and what use case am I applying it to? And then something I didn't talk about here, and maybe it's outside the scope of this podcast, is testing. So doing something like test train split, where if you take 70% of your training data and use that to build a model, and you hide that other 30% from your model. But that's the data you would use to make predictions over that. If you know all the answers to the test, well, now you can start assessing the performance of your machine learning classifier. Like, how accurately is it making predictions on this data that it hasn't seen before?
Sure. Yeah, that's cool.
Yeah. And once you understand just the basic workflow, then I would go and read. There's a couple published books out there now of applying data science to cybersecurity, and a lot of good publications from pretty popular companies.
Austin's got a bunch of awesome stuff out there. He's taught a bunch of classes at Black Hat in the past, and his team will probably do similar things in the future, a bunch of summit talks and otherwise. Where can we find things that you have put online already, Austin? Do you have any blogs, LinkedIn, Twitter, stuff you want to shout out?
Yeah, sure. My Twitter's just twitter.com/huntoperator, or you can just find most of my publications at austintaylor.io.
All right. Well, with that, thank you very much for joining us on the Blueprint podcast. Thanks for talking data science with me.
Thanks, John. This is a lot of fun.
Hey, Blue Teamers, I hope you enjoyed today's episode of Blueprint. If you've got a second and want to help support the podcast, please subscribe and leave us a review on Apple Podcasts. It would be really, really meaningful to us. And if you have any ideas or suggestions, I would love to hear them. Your reviews are going to be one of the best ways to help others find this podcast. So anything you could do would be a big help. As always, thank you for listening. You can connect to me on social at SecHub, SECHUBB on Twitter, or on LinkedIn. So until next time, thank you for listening to the Blueprint Podcast.